All right, let's just jump right in. We are going to be tackling one of the biggest questions you can possibly imagine, and we're going to use a really fascinating and frankly pretty wild theory of physics to guide us.
So what does it actually take for something to exist? And I mean anything, not just you and me, but, a rock, a star, maybe even an idea. What are the absolute non-negotiable rules for just being? It sounds like a question for philosophy, right? But the theory we're looking at today says the answer is buried deep in the fundamental laws of physics.
So our guide for this whole explainer is a series of papers by physicist Xidong Liu, and it's called the Genesis Trilogy. And it's this incredibly bold attempt to build a thing that can exist and observe the world from the ground up, using nothing but the first principles of quantum mechanics. Now, here's what makes this so cool. It's not just a boring list of ingredients for reality. It's actually a story. It's an unfolding drama of ascending crises. You see, each layer of reality literally pops into existence to solve a life-or-death problem that was created by the layer right below it. In this view, existence isn't a given. It's built out of sheer necessity.
Okay, so let's start where it all begins, at the absolute bottom floor of reality. Part 1 of the trilogy is called Half, and it completely redefines the stage on which everything, and I mean everything, happens.
Before there's space, before there's time, long before there are separate things, the theory says there's only one thing, the Alea field. The best way to think about it is like a single, universal quantum state. It's this featureless, primordial quantum soup that contains the potential for everything, but the reality of, well, nothing. Not yet, anyway.
And this picture perfectly captures the first huge, mind-bending idea. The theory argues that geometry, the shape of space, the very idea of here and there, it isn't fundamental. It's not some pre-existing box that stuff gets put into. No. Instead, a specific geometry actually emerges based on how you access information from that underlying quantum soup. Different ways of looking, or what the theory calls different coarse screenings, literally pull different geometric worlds out of the exact same fundamental reality. It's wild.
So let's be super clear about this, because it's a total flip of how we normally think. We usually just assume space is a fixed container and objects move around inside it. But in this framework, nope. Space and the so-called objects in it are defined together by the act of observation. So it's not just one reality with different viewpoints, it's one fundamental state that can give birth to entirely different, incompatible geometries.
And boom, right away, this creates our very first survival crisis. I mean, think about it. If the very stage of reality, space itself, is this shifty, observer-dependent thing, how can anything stable even exist? How does a thing hang on from one moment to the next if the ground is literally changing under its feet?
Well, the solution to that crisis brings us to the second part of the trilogy, called Q-Rafe. And this part answers the question, in a world where geometry just emerges, what does it take for a thing to hold itself together and not just melt back into that quantum soup?
And the answer, it turns out, is a kind of natural selection, but happening at the most basic level of physics. See, not all possible blobs of matter and energy are created equal. To survive in this shifty world, a subsystem can't just be some random clump. It has to be built in a very, very specific way.
This is what the theory calls algebraic natural selection. For a subsystem to keep a stable boundary and actually persist through time, its internal operating system, its control algebra, has to be mathematically compatible with the geometry it's helping to create. Now, you don't need to know the math, just the name. It's a Clifford algebra. This structure is the only one that has the right toolkit for the job. Anything else is just unstable. It dissolves. It's literally survival of the stablest.
Okay, so crisis number 1 is solved. We now have a stable thing that can persist. Awesome. But that's not nearly enough to be a real agent, right? An agent needs to interact with the world. It needs to process information. It needs to adapt. And this leads to a whole new cascade of internal crises. The problem is no longer just about existing. It's about processing existence.
And this brings us to the final part of the trilogy, T-Dome. This is where we build the internal architecture an agent needs to manage reality. And what's incredible is it's this chain of logic where every single solution creates its own brand new deadly problem.
So problem number 1, instant forgetting. An agent that only experiences the present moment, it's what's called a Markovian system. It has no memory. Its future only depends on right now, not the past. So it can't learn, it can't plan, it doesn't really have a continuous identity.
The solution, of course, is memory. The agent has to evolve the ability to accumulate information, to connect the past to the present. This is called non-Markovian memory, and it's the very first step toward building a continuous self. But you guessed it, this creates a new, equally fatal crisis: information overload. The universe is just bombarding this agent with a nearly infinite amount of data every single moment. If it tries to remember everything, its brain, its finite processor, will be completely fried. The source actually calls this the memory catastrophe.
So what's the solution? A filter. The agent needs a biased, simplifying mechanism that just ignores almost everything and focuses on a tiny, manageable slice of reality. The theory gives this computational shortcut a name: the ego. Now, this isn't the Freudian ego. It's a necessary information processing strategy. It's a way of making an infinitely complex world simple enough to deal with.
But now we have the next crisis. The ego saves the agent from being overwhelmed, but the price is that it makes it delusional. Its model of the world is now fundamentally biased, it's incomplete. And over time, that flawed model is going to drift further and further away from what's real, leading to catastrophic mistakes. This is the delusion trap.
So the final piece of this incredible puzzle is self-correction. The agent has to develop a feedback loop. It has to watch for its own mistakes, that mismatch between what it predicts and what actually happens, and it has to use that error signal to constantly update and recalibrate its own biased filter. This is what keeps it tethered to the real world, what stops it from just spiraling off into total delusion.
So after this whole journey, from that featureless quantum soup all the way up to the complex internal logic of a self, we arrive at a really profound conclusion about what it actually takes to be a thing that exists and observes.
The theory shows that a stable, observing agent isn't just one thing. It has to be a structure with 4 distinct but totally inseparable components.
And here they are, the 4-part architecture of being. You need 1. An external geometry that emerges from how you look at the world. 2. A stable internal control algebra, that Clifford algebra we talked about, that lets you persist in that geometry. 3. You need a biased memory with an ego filter to stop you from being overwhelmed. And 4. A self-monitoring loop to correct for the ego's delusions. Every single part is a solution to a crisis that would have otherwise just wiped you out.
This quote from the paper itself just captures the whole relentless logic of the process perfectly. Existence isn't some peaceful state. It's like climbing a ladder of solved problems, where every single step up just reveals a new, terrifying drop.
And that leaves us with this final, really powerful thought. Maybe existence isn't a passive state of just being. Maybe it's an active, relentless, and very costly process. The constant, difficult work of not falling apart and dissolving back into that infinite potential we all came from.